Welcome back. This video provides explanation about Close Neighbor Algorithm. So this algorithm was developed by Boy and Cheng in 1991. You can access this paper. So basically there are metric A or metric I, basically metric initial, which show about the part and machine incidence metric. So number 1 indicates machine I is used to process part B. Basically, for example, this one, machine 1 is used to process part 4. This is the initial metric. And then after that, we can calculate or determine matrix B, which is the closeness metric. Basically, this is the mathematical equation, but for simplicity, basically matrix 1 and B, matrix B, basically if there is the same part for machine 1 and machine 2, for this one we can calculate 1, so 1 and then 2, so this 1 2 is basically from there. And then this one 1 and 3 0, because there's no similar 1 and 3. Okay, and then after that we can calculate the sum for the row. We got 7. And then this one is transform matrix. This particular one is the transform of matrix. Okay, and then we can find the maximum sum. We can find the maximum SE from this one. We got this one 6 done. This one as the first V1. Okay, for this one particular V1 is metric machine number 2, because the S2 is marked. And then number 2 we can determine from this one. We got the highest B to highest B, 4 and 4. Alright, and then 4 and 6, 4 and 6, the highest sum is basically 6, so we select 6. And then for number 3, since we select 6, we can know this one. Oh, 2, but 2 has already selected, so we can choose this 4, because this one is 2, so we can choose 4, because B for 6 is the maximum. We can choose this one. And then number 2 has already selected, number 1, number 6 already selected, and number 8. Alright, and then number 1 and number 8 has exactly the same sum, which is 7 and 7. So, but we can select the lowest index, which is 1. Alright, the lowest index is 1, is smaller than 8. We can choose 1. And then after 1 has been selected, so this one 8, we can choose 8 for this one, until we got the whole row basically. And then we can rearrange the machine row. Alright, we can rearrange as the previous V order, and then we can divide it to half. And then after that we can calculate the half one. Basically for this one is 1, this one, and then for this one is 3. Alright, and if a half 1 greater than half 2, we can make a mark and order it as 1, like this. This one is 4, meanwhile the second half is 0, so we can mark it. Okay, 1 and 2, 3, we got the order. And then after that we can redivide again for the 2 half on the lower part, and then we can calculate this. This one is 1, this one is 2, so this one is not achieved, but for this part has been already. So from this one is not. Nah, but for this one is 1, and then this one is 0. The bottom part is 0, so we can make it as 4. And then the last one we can divide it again, but since it's only 1 1 1, we can just put the number after 4, 5, 6 and 7. Okay, and then we can rearrange the part row based on this order. Okay, and we've got 2 cells as so. Okay, and then how to calculate the group efficiency? Basically by this formula, 1 divided by OX. OX is the number 1 outside the cell, this one OX, and then the total of 1, while Sn is basically the space occupied, this one, and then the total space within the cell. Alright, so from this formula we can get 3, basically this one, 1 2 3, with the total number 1 is basically 25, and then the number total occupied, this one, we can calculate all of this total occupied, and then we can calculate total space within the space. So we got this 20 and we got this 9. Okay, so from this calculation we got 82% the effectiveness. Thank you.